The Caribbean, and by extension the world, requires a new way of thinking if it is to survive the impacts of climate change. And what better place to nurture that new way of thinking and innovation than the University of the West Indies? Our feature presenter today is a hydrologist specializing in catchment hydrology, particularly stream flow generation and the application of stable isotope and geochemical techniques to understand water movement. He has conducted research in northern peatlands in Canada, tropical dry forests in Mexico, and a range of wet tropical locations in Trinidad. He's a lecturer and the head of the geography department at the UWI St. Augustine. He currently leads the tropical hydrology. Ladies and gentlemen, our feature presenter, Dr. Kegan Farrick.
Good morning, everybody. Greetings to all officials of the Ministry of Public Utilities and other government agencies, the Water and Sewerage Authority, the Water Resources Agency, specially invited guests, and other presenters. My name is Dr. Kegan Farrick, and I'm a hydrologist and head of the Department of Geography at the University of the West Indies. So it's really an honor for me to be able to present today at the Adopt a River Conference. So the title of my presentation is What Lies Ahead and Also Beneath, Advancing Our Understanding of the Hydrology in Trinidad and the Caribbean. So what I wanted to start off on today was a bit of a look at water resources from the Caribbean perspective. And the reason I am looking at it from a water resources perspective initially is that I think as a region, we've put a lot of effort and work into characterizing our water resources. And just for instance, this figure that I have on the screen shows the total renewable water resources in a few of the English-speaking islands in the Caribbean. And I was actually able to put together this figure relatively easy. I can just go to the FAO Aquastat site and collect this information, for say the past 10 years or the past 30 years. And what this actually shows is the total amount of renewable water resources in different islands. So we have, for instance, Jamaica with the highest number of total renewable water resources, followed by Trinidad and Tobago, and then some of the other English-speaking islands. But what I really wanted to focus was that the ease of accessing some of this water resources information. And again, I think we've done really well as a region in terms of trying to understand how much we have available. Even when we look at this table here, it shows the main sources of water supply for different islands in the Caribbean. And it all depends on the type of water, so groundwater, surface water, desal, rainwater harvesting, and then it kind of characterizes the islands based on their geography. And what we can see, just a sort of characterization of the main sources of fresh water for each island. So we have, for instance, groundwater that is dominated by Bahamas, Jamaica, Barbados, for example. So that's sort of a primary source of water. Whereas countries like Trinidad, Cuba, St. Lucia, we use surface water. And by surface water, we're talking about your rivers, your streams, your reservoirs. And then, other countries use rainwater harvesting or desal. So again, this is really to highlight how well we've done in terms of characterizing how much water we have and where those main sources of water come from. But I still think that the research in terms of water resources is slowly building. And what I mean by that is that I have recently been working on trying to write a review on the water resources and the hydrology of the Caribbean. And I actually have one of my undergrad classes. We do this exercise every year. And students often find it, a bit challenging to get some of this information. So we have information, and I just have a few examples up there from either scientific articles or technical papers, or, we have white papers, for instance, that look at water resources in the Caribbean, and it really focuses more on management, etc. And even though I think we've been building slowly, I feel like we can do a lot better. So in a recent review of some of the water research in Latin America and the Caribbean, I was reading this paper, and one of the things that the authors said really stood out to me. And that is, of the literature, we found very little focused on Caribbean countries. And this lack of information limited subsequent analysis. And if you have a look at this really interesting figure, it might seem a bit complex, but what it's actually doing is just sort of sorting countries out based on type of research clusters. And we see areas such as socio-hydrology, or even looking at the physical sciences. They've grouped different countries and sort of the connectivity between countries. But the lack of knowledge and understanding of our water resources and our hydrology is a real challenge for us in the Caribbean. So, I'm hoping with this presentation that I can highlight some of the newer technologies that we are using in my lab group at the University of the West Indies and sort of provide a way forward on really improving our understanding of hydrology in Trinidad and the Caribbean. So again, I really wanted to illustrate that we have a lack of information on water resources, and it's really, really true for hydrology. I mean, I have the classic sort of, precipitation coming in, ET, runoff, right? But as a country and a region, again, we have very little understanding. So I've been working on this review for a while. My students every year, they dig into the literature to see what we find. And we really don't have much in Trinidad. I would say Jamaica, from the English-speaking part of the Caribbean, has sort of led the way. And Puerto Rico, they have the most information when we think about hydrological processes. So we really, really don't understand much about the hydrology. So you're probably wondering, well, why is that important? And it's important because these systems are actually quite complex. It's not really a simple inputs versus outputs. So I'm sure a lot of you probably remember, pictures like this from your primary school days, even secondary school. And I think a lot of people simply think, it's just inputs, outputs. We have rain, runoff, it goes back into the sky, it comes back down as rain. But in reality, the systems they're very, very complicated. So this is a really excellent example of some work done in South America in some high elevation mountainous areas. And we have two different images here. One is in the wet season and one is on the dry season. And what those red arrows indicate is that the way that water moves through your soil systems is really, really complex. It's not just simply water moving over the surface or going beneath the surface. It follows different pathways. It comes from different layers. And what I really, really like about this image is that you can see differences between the wet and the dry season. So there's something on this image called contributing area. And what that means is that there are particular parts of your catchment that are going to add and contribute water to your streams. And you can see in the dry season, right, so figure B, on the dry season, it's a lot smaller and a lot lower down than in the wet season, right? So depending on the seasonality, on the different conditions, what we see, right, and what we understand it's very, very different. So hydrology is not just simply inputs and outputs, but it's rather a very complex system. So we really need to push to improve our understanding in these areas. And it can be from runoff to, groundwater flow. I think those are sort of the two areas that I've highlighted in my reviews. And I'll sort of give you an example of this complexity. We can use a local Trinidadian example, right? So we have our Hollis Reservoir, which is located in the northeast of Trinidad. And if you look at this image, you see the nice reservoir, but surrounding the reservoir are these hills and these mountains. So one of the things and the questions I have always had is, well, how is runoff generated? I know it's a complex process that is often affected by land cover, slope, soils, the amount of rainfall, right? So we really don't understand these types of things. And I think if we put a real effort, collaborative work through the university and the different agencies, we will be able to really improve our understanding. And that could really help us long term, in managing our systems. And again, it's really, really important because when we're constantly talking about climate change and what type of impacts climate change would have. And in the most recent IPCC report, I don't want to say it's grim news, but it's not the best news. But I always want to take this news and let's see what solutions we can come up with, right? So in the Caribbean region, for instance, we're going to expect, a real reduction in precipitation. So we're looking at anywhere between 10 to 15%, let's say, reduction in precipitation. So what kind of impacts will that then have on our hydrology? We know it's going to affect water resources, but we don't know how it's going to impact the hydrology of our systems. So one of the real messages I wanted to get out here is that understanding our hydrology is key in the sustainable management of water resources. I've gone to different meetings, I've spoken to different people, and we've had this big focus on water resource management, integrated water resource management. But it's often a little bit of work and a little bit of research and understanding the key hydrological processes. So let's not think about it in a negative way. Let's use these projections as a way to mobilize, to start making some changes and understanding what we have in Trinidad, and by extension, I think, through the Caribbean. So we've been trying to address things like this using traditional methods, right? So I think a lot of people will be, familiar with these types of things. So we have rain gauges. So we have our classic tipping bucket rain gauges. We have met stations to measure evaporation. We have Stirling wells. So I'm sure, a lot of people have probably seen Stirling wells or monitoring stations around Trinidad and Tobago. I have a tendency as a hydrologist, every single time I drive over a stream or a river, I must look inside. So I always have to see if I see a Stirling well, right? And I see we have new monitoring systems around the Caroni River. So that's really, really excellent. And I think we actually have a pretty good groundwater monitoring network as well in the country. Now, one of the things, that I wanted to highlight is we can easily reproduce the information from these types of instruments, but sometimes they're expensive. And a lot of times they're also prone to vandalism. So I've had my personal experiences, going out into the field, happy as can be, and get into an instrument and it may be gone. A battery might be stolen. Most of the times people like to take batteries or some wiring or something like that, right? So you have a tendency to experience some kind of vandalism. But, we have new ways and new tools and techniques that kind of help us offset and to basically complement these types of analyses. And that's what I'm going to look at right now. So I want to say help is on the way. And help is on the way through training. So these types of tools and techniques we are typically using in my research lab at the university, so in the Department of Geography. And I've also incorporated these types of things into my classes. So we're getting a new generation of students and people coming out who have a better understanding of using some of these advanced tools and techniques to really improve our understanding of hydrology in Trinidad and Tobago. And by extent, they graduate and head out through the Caribbean. So I'll be talking a little bit more about stable isotopes, remote sensing using drones, and some of these smart systems. So we in our research group mainly use stable isotopes. That's one of my real areas of specialty and passion. It's something I really love doing. And the reason I like it so much is that we can use it to characterize so much of the hydrology. So just looking at that figure, that catchment, and we have so many different things we can use it for. You can understand where water is coming from in a catchment. Is it moving on the surface? Is it moving 10 centimeters, 50 centimeters? How does it change with different rainfall amounts? We can characterize, the storage and recharge of groundwater systems. We can trace pollutants. We can trace contaminants. We can look at carbon cycling, for instance, in watersheds, all using very simple isotopes. And what I mean by simple, it's really simple. So that little bucket up there, we do an exercise every year in my class called hydrology at home. And students actually design rain gauges and different instrumentations using very simple material. And we can have, take an adopt a river approach and have communities involved. We've made rain gauges. You simply have a rain gauge with a bucket, a plastic funnel on top, sealed well. We pour mineral oil inside, which is relatively affordable, right? And that prevents evaporation, and that bucket collects rainfall. We go out every week, every 2 weeks, or every month, depending on what you want to achieve, and we collect samples in little glass vials, and we send those off for different types of analyses, right? Isotopic analyses. So right now we are using these types of techniques to look at the transmission and the storage of water in different watersheds. So the figure I have below with all those different dots, we have some that have rainfall, different streams, soil, springs, groundwater, etc. And what we're basically trying to understand is where does the main sources of water come from, right, in that landscape. So we use different techniques that we can say, well, in a dry season, it seems most of it is coming from a groundwater source. But in a wet season, it all moves to shallow soil water sources, for instance. And we can also use it to do what we call transit time, or we basically try to see how much water a catchment can actually hold. So in some instances in the tropics, what a catchment can hold, it takes about 100 to 200 days for rainfall to really fully move through a system really well. And it tells us about that storage, how it releases the water, and then we can kind of put that and link it with climate change and figure out, well, how will climate change affect it? How much water can we pull from a system? How would land use change affect the storage capacity, right? All of these things are really important when we're looking at our water resources. A really nice example, so this is not really stable isotopes, but it's a recent study done in Tobago. And what the authors did here is that they used other tracers, environmental tracers, such as tritium and sulfur hexafluoride, to look at the ages of groundwater in Tobago. So these are really nice maps, lovely colors, right? And so the redder the color, basically that indicates that the groundwater is a bit older. And the older the groundwater source means that it actually probably takes longer for that rainfall to make its way down through the surface and eventually get into your aquifers. So maps like this, information like this using different tracers, help us to manage our water resources, but also understand the processes that are taking place. In our lab, we've also been using and sort of pioneering the use of these stable isotopes in the tropics, right, to look at restoration activities, things like agroforestry. So we currently partner with I Am Movement on one of their projects looking at quarry restoration in Sangre Grande. So what we're using are vetiver plants to see how that helps in restoring some of these forests. And what we're trying to track is where do these grasses pull and use water from. And we've sort of kind of hypothesized that they actually take water from deep down, pull it up, and then that water becomes accessible to the young tree saplings. And we're also looking at cocoa agroforests and how shea trees actually compete with cocoa trees for water use. So all of these are different ways in which we utilize isotopes. So I've only mentioned, I kind of like just hit the tip of the iceberg, and there's a lot more that we can utilize with these techniques. So moving on now to something I have recently started to get involved in. So remotely sensed data, so we're talking about the satellites passing over the Earth's orbiting Earth and taking these images. So we can utilize some of those images at different wavelengths to look at water resources, to characterize rainfall runoff models and things like that. But one of the major challenges we have in the Caribbean is often the size and the scale. So these satellite images look at stuff over a much larger scale. But think about some of the streams that you would encounter, not the Caroni River, but some of the smaller ones. They're very small. Sometimes they can be like 1 to 2 meters wide. And these images aren't always able to capture that scale. So one of the things that we have started doing in our lab is to start to develop some drone and UAV technology. So we're trying to use these low-cost drone systems, these low-cost camera systems, combining them together to try to understand what type of hydrological processes are happening, to understand sources of contamination, sedimentation, things like that in our rivers. And I think sort of these type of technologies will really help in Trinidad. It can be a boost to the WRA, to WASA, and be used in the Caribbean. So kind of imagine, you're out in the field, we just have to collect point samples of water for water quality. But these drones can span over an entire stream, right? Take the images, and we'll better be able to assess the overall quality of a river or identify point sources of contamination. So we're basically trying to utilize very low cost methods, right? Because money and funds are always a challenge with us here. So we're trying to develop these low cost methods to assess hydrology and water resources and water quality in Trinidad and Tobago. So the last thing I wanted to talk about in terms of advanced technologies were these smart systems. And this is something sort of new to me. One of my students actually brought this to my attention. And these systems actually utilize what we call the Internet of Things. And I don't know if people have heard of it, but you probably experience it in your day-to-day life. So for instance, a good example would be you've left your house, you have your AC running, and instead of having to drive and head back home to turn off the AC, some of these air conditioned units can be set up and linked to your Wi-Fi, right? So you can hop on your phone, pull up and connect to your AC unit and turn it off from home. So that's the basic concept of the Internet of Things. And it's relatively readily used, for instance, in greenhouse applications. So I think some people in Trinidad use it for greenhouses. But we can actually adapt this technology for our own sensors to monitor water quality, for instance, so you get real-time data, and water quantity, which comes in really handy for floods. And the nice thing is that nowadays, loggers and things like that are quite expensive. There's data transmission technology available, but again, you have to buy that from a company, and it could cost quite a bit. But we have new systems, for instance, things like Arduinos, for instance, that you can program yourself and connect directly to your own sensors, because sensors tend to be a little bit cheaper than the loggers. Things like Zigbees, for instance, you can then connect to your Arduinos. So we can do this stuff in-house, right? Using our own skills, right, through computing, a little bit of electrical work to connect our sensors, send that information, right, to a cloud system, and then back into your office or to your phone. So you can monitor things, right? You can see if something is wrong with your system, right? So you're not waiting like 2-3 weeks to have to go out. So these are some of the really, really advanced, I think really neat, interesting technologies that we have available. And I definitely know with, all the younger people coming up, they're way more advanced than me. They have a better understanding of these types of systems. So I could only see positive things moving forward. So I've presented, a lot of information on different tools and techniques that I use in my lab group, and those smart systems that I think are really, really applicable, in this day and age. And those things begin even at the primary school with such a focus on STEM and programming and things like that. So it begs the question then, where do we begin? Where do we start off applying and utilizing these tools and techniques? So I think we've already started that process. We have organizations like the Adopt a River program, for instance, that does excellent education and outreach at the primary, secondary school levels. So, you've been encouraging a love and passion for the environment and a love and passion for water resources. And I think this education is actually starting to translate into the university, because over the past 2-3 years, I've actually gotten emails from students wanting to be hydrologists now and wanting to get into the water sector. And I mean, I've been at UWI only for a short amount of time, but when I talk to others, I don't think that is something that's common. So I definitely think it has to do with some of this education and outreach that is being done by the Adopt a River, by WASA, by WRA. And you also have really good connections to the communities, right? So in terms of water quality monitoring. And my vision is that, we can train them, for instance, to collect water samples for isotopes. We can span a whole network of Trinidad and Tobago, just training them how to do these types of things. Because oftentimes getting to locations is often a challenge for us. We can only do so much in a short amount of time, right? The next step will then come, obviously, at the tertiary level. So I'm from geography, so, I'm going to push my discipline a little bit there. And the reason for that is that we cover so many areas that relate to water resources and advancing these tools and techniques. My graduates, so the students in my lab, have all come from these programs. So they come with the necessary skills to really become more advanced hydrological practitioners. So we teach courses, for instance, in hydrology, water resources, GIS and remote sensing. We do environmental modeling, and we cover climate change all in our program. So they come in with a really, really good background knowledge to start to apply these tools and techniques. And then we have our local organizations, so WASA and WRA, who monitor our water resources, take our measurements of our water resources. So I think having a really good sort of collaborative research effort between the university and our water resources will really help us understand help us to characterize these complex hydrological systems. And what I sort of wanted to end on was this example here. Over the last 10 to 15 years, there's been a really concerted effort to increase the hydrological understanding of what they call the Paramo system. And that occurs along the Andes in South America. So a lot of this research has been done in Ecuador and even parts of Costa Rica, so even parts of Central America. The reason for that is that these mountains are what they call the water towers of South America. Stream flow, everything is generated in these mountains and flowed down to the population in the sort of the floodplain, the flatter areas. And we can draw very, very close parallels in Trinidad and the other islands in the Caribbean that are mountainous or volcanic. So they've put a lot of effort and collaborative work between the state organizations, so the water resource agencies, and the university to really, really understand what is happening in these environments and to characterize the hydrology. So now that they've done that, they're able to better plan and manage the water resources sustainability and also see how projected climate change may impact it. So they're able to create more resilient, adaptive systems down the road. And I think this is something that, we can definitely do in Trinidad and Tobago, and also by extent the Caribbean. We have other water resource professionals in the Caribbean. So I think this type of collaborative work is really, really where we need to begin. So even though I may have started off with, a little grim news with regard to climate change, I wanted to end with something positive. And I could only see positive things coming from collaborative work, collaborative research. And I think we are in the process of, getting all of these types of things done. So thank you very much for the opportunity to present. And I will be around if anybody has any questions. So thanks again.
Thank you very much, Dr. Farrick, for that very informative and insightful presentation.